Hello everyone, welcome you all in my YouTube channel. Today we are discuss about the new topic of chemical thermodynamic is a isothermal process. Okay, in chemical thermodynamics there are lot of thermodynamic process will be there. Okay, and one of the type of thermodynamic process is isothermal process. Okay, what is the meaning of isothermal process? First, you have to write down the meaning of isothermal process. Isothermal means at constant temperature should be constant. Okay, temperature should be constant. Okay, if the temperature is constant, the value of T is 0 and the change in temperature also should be 0. Okay, change in temperature should be 0. Okay, uh, and change in temperature is denoted with the dt and dt is also 0. Now move to the next point is if you find the temperature should be 0, but in for ideal gas equation, how can we decide on the constant temperature? What is the value of ideal gas? Okay, and how can we relate the isothermal process with the ideal gas equation? Okay, now we have to write down the subtopics in isothermal process for ideal gas equation. Okay, for ideal gas equation, for ideal gas. Okay, the ideal gas equation, the value of ideal gas equation, the formula for ideal gas equation is PV is equal to nRT. Okay, or this is value are considered to be a closed system. Okay, in closed system you can see that the n value is always unit, like number of moles is always 1 and n will be always constant in closed system. Okay, n is always constant in closed system. R is also constant because R is the universal gas constant. Okay, it should be also constant. Temperature should be constant. Okay, in isothermal process. Now the value of PV is constant because all the three terms like nRT, all the three terms should be constant. Then value of PV is constant, and in place of PV we also write P1 V1 is equal to P2 V2. Okay, okay, right? If PV is equal to constant, then constant is denoted as the K and PV is inversely proportional to the volume. Okay, and this is the relation between the ideal gas and isothermal process. Okay, and this equation is called as Boyle's law. Boyle's law. Okay, now we move to the next equation of ideal gas equation for uh, isothermal process. In closed system we generally consider the ideal gas equation for any closed system is delta U is equal to NCV delta T. Okay, and this value is for internal energy, and this value is always constant for any closed system. Okay, and the value or the delta should be delta T should be constant. Then the value of NC delta T will be 0 and internal energy will also 0 in isothermal process. Okay, now we can move to the another subtopics. The first law of thermodynamics. Okay, in isothermal process we can write down first law of thermodynamics in isothermal process. Okay, what is the value of first law of thermodynamic in isothermal process? the the definition of isothermal process, or the formula of the first law of thermodynamics is Q is equal to W plus delta U. Okay, you already know the value of delta U is 0 according to the isothermal process, because the temperature should be constant. Okay, then the value of delta U is 0, then Q is equal to W. Okay, yani, if you directly say that the charge is dependent on work. Okay, if the charge increases, the work is also increases in the system. Now we can look here, some condition to be the perfectly isothermal process. There are some condition also there to prove this process is a perfectly isothermal process or not. Okay, the condition is condition to be perfectly isothermal process. Okay, what is condition? Okay, there are some condition will be there for the isothermal process in any medium, like the reaction should be very slow. First condition is reaction should be very slow. Okay, why it is why the reaction should be very slow? In slow process you can easily determine the every step of the reaction. You can easily find the every step, their energy. Okay, their change in volume, their temperature also you can find easily. Okay, in fast reaction the change in between the process you can't see easily, you can't determine. Okay, but in a very slow process you can easily determine all the information of the reaction step. Okay, if we consider the one beaker. Okay, you can look here, I can take a one beaker. In that beaker, okay, amount of substance will be there in the form of water or in the form of ideal gas. Okay, sorry, in the form of ideal gas. This is the ideal gas. Okay, now we are applying the force from upward using piston. Okay, this is a piston. Okay, and the dq is slow process. Okay, slow hit. What is the meaning of dq? Dq is nothing but we are providing some amount of heat to the ideal gas. This is a very slow heat we are providing to the ideal gas equation. If any object getting the slow heat, they can uh, slowly they can get heated up. Okay, if this process is very slow, you can say that in that process delta t will be 0. Okay, and w is equal to q. Correct, and this is a conducting boundary should be there. For conducting boundary, why it is required? Because the conducting boundary is transfer the heat from their walls. Okay, easily. In isothermal process there are also some concept will be there, like we have to learn about this isothermal process is in isothermal process. In isothermal process we know the value of T is constant. Correct, value of ideal gas is P1 V1 is equal to P2 V2. Okay, instead of P1 V1 you can also write the value of P2 and V2. Okay, both the value are same and the reaction should be very slow. Okay, slow reaction, and in presence of conducting wall. Correct? This is the condition for isothermal process. And ideal gas should be required. Ideal gas must be required. In ideal gas, you can see the delta U or change in internal energy is also zero. And if the change in internal energy is zero, the value of Q is equal to the value of work. Okay. The amount of heat you provided to the system, the same kind of work will done by the system. Okay. Now, the next point is work done in isothermal process. Okay. And for that you can find the one expression for there for work done in isothermal process is the next point you can write down here. Work done in isothermal process. Okay. And for this you can find the one for this work done in isothermal process. There are some uh, expression will be there for finding the work done in any isothermal process. The definition of work done is W is equal to integration of P dV. Okay, the value of work is at constant temperature, because we are considering the isothermal process at constant temperature, and temperature should be zero. Okay, the temperature should be zero. Okay. And ideal gas, if the ideal gas is expanded, then the value of V1 is also considered to be V2, and P1 is also considered to be a P2. Okay. Now the ideal gas for N mole. Okay. For ideal gas, using ideal gas, the value of N is mole. Okay, it should be 1 mole, 2 mole, according to your need. You can write down the number of moles. Okay. Now the W is integration of, in the place of PV you can write down the nRT divided by V multiply by dV. Okay. W is equal to nRT. nRT is the constant value, that's why we can take it to the take out to this integration. Okay. And dv upon v. Now the W is equal to nRT in bracket dv upon dv upon v is log v upon v2 upon v1. W is equal to nRT in bracket log e v2 minus log v1. Okay, this is the value of work done in isothermal process. Okay, you can also simplify this equation in W is equal to nRT log E outside the bracket V2 divided by V1. Okay, this is the final equation of work done in isothermal process. Okay, now we can also write down the value of work done by the system. Okay, work done by the system. Now, what is the value of work done by the system? We already know the work done in the system is W is equal to nRT log E V2 divided by V1 for volume term. Correct. We can also write down in the pressure term also nRT, because V2 upon V1 is equal to P2 upon P1 is also the same. Then you can write down the P2 upon P1 in in pressure term. Okay, in pressure term both the value are same. We already know the value of P1 is equal P1 V1 is equal to P2 V2. Okay. Now the value of P1 V1 is equal to P2 V2. You can place on you can write down in the place of nRT. Okay. P1 P1 P2 is equal to V2 V1. Okay. And this is the inversely proportional to each other. Inversely proportional to each other. Okay. If the n is the number of moles are not given. Okay. If the value of n is not given, in that condition you can only write down the value of P1 V1 is equal to nRT. Okay. And P2 V2 is equal to nRT. Correct. And in the place of nRT you can write down in the place of nRT you can write down the value of P1 V1 log E in bracket V2 V1. Okay. You can also write down the P2 V2 log E V2 V1. Okay. And the next one is P2 V2 log E P1 P2. Okay. And P1 V1 log E P1 and P2. Okay. And this is the expression for the work done by the system and work done on the system. Both the equation are I can prove here. You can also see that if any things found, if any mistake you found, please comment on that mistake. And you can also contact me the personally through Instagram and my Telegram channel. Okay. And please do not forget to subscribe my channel and share with your friends also. Thank you so much for watching my video. Please subscribe my channel. Okay. And also share with your friends. Thank you so much.